Hi. So in this part we're going to talk about solving inequalities. This seems to give people fits, but it's really quite fun once you figure out how to do it. It involves, lots of it involves just being able to understand and graph the functions. So in order to focus our discussion, let's talk about this very specific problem. So we want to solve the inequality x times the absolute value of x plus 5 is less than 2. So the place to start with this problem is to think about, let's graph the function. Let's first graph this function, x plus 5. Okay? Let's graph this function. So what you should notice about this function as you profile it is that it has roots at 0 and minus 5. Okay? Let's put minus 5 down here. Okay? So this is, if you notice, if we FOIL this out, we would get x squared. So the leading term is positive, the leading coefficient is positive, so that tells us that this is a parabola opening up. It has roots at 0 and minus 5, so we can pretty easily draw the graph of this function. Okay? Even if it's just a sketch. The other thing that we know, or you should know, is what's really interesting is that the vertex, or the axis of symmetry of a parabola, is halfway in between the roots. So if we take the average of the two roots, minus 5 and 0, we are going to get minus 5 halves. Okay? So that tells us that the axis of symmetry here is at minus 5 halves. And that means that this point on the parabola is a minimum. Right? We know that this is a minimum. These are all things that we know from our section, say 2.2 or 2.3 on quadratic functions. The other thing that we can calculate is by plugging in minus 5 halves, we could figure out what this value is over here, and I'll leave that as a calculation for you. Okay? Alright, so now we have the shape of this parabola. Now how do we figure out what x absolute x plus 5 is? And this is quite interesting, because normally you think when you slap absolute values around something, you're going to make it positive instead of negative. And here, in fact, what's going to happen is that we are going to take this parabola, and we are going to take this part of the parabola that's less than 5, and it's going to flip over. It's simply, all we're going to do to compute the graph of absolute x plus 5, this function, is to take this part of the parabola that's less than minus 5 and flip it down. And that seems super counterintuitive. I get it, that when you think, normally you think when you put an absolute value on something, it's going to make it positive. But the logic is quite clear, is that what's happening down here below minus 5 is that both the terms x plus 5 and the x term are both negative, and a negative times a negative makes a positive. That's why this piece of the function is positive. But when we take away one of those negatives, when we take absolute value x plus 5 and make that part positive, then now a positive times a negative creates a negative. And that's why you have this flip down here. Okay? And that explains the shape of our function. Now, to solve this inequality, we only have to add one extra piece to the puzzle, and that right there, at least to solve this geometrically, is the line y equals 2. Okay? So y equals 2 is a horizontal line here at y equals 2. Okay? And the question really is, if you notice, so let's draw our actual function in blue. Okay, this piece is this red piece here is no longer part of our function. Okay, it's what we know is x absolute x plus 5 is the blue modified quadratic function. Okay, y equals 2 is the horizontal red line. And really the only point that we've got to find is this point right here. Okay? And then it should be clear that our solution set, so this is our mystery point, let's call it P. Okay? And we're going to write an equation to find P. And this is how you should be thinking about it. Okay? This is how you should be thinking. Hopefully, if you're doing your work and understanding graphs and functions and equations, then you're able to think along the way that I'm talking along. Okay, so what you should know so far, hopefully, what you be able to figure out is that the solution set is going to be all the points where the blue curve is underneath the horizontal red line, and that would be, I'm going to indicate that in what color should I use now? Let's use red on the x-axis. That will be all these points up to and including, sorry, not including an open circle at P, because at P we're going to be, the two functions will be equal and we're looking for strictly less than. And that's going to be all the points on the x-axis up to and up to but not including P. Okay? So our solution set is going to look like this: minus infinity to P, open. Okay? Our only job now is to find this point P. I'm going to clear the boards and we're going to write an equation. So while I'm clearing the boards, what I want you to do is I want you to think about how you would write the equation that we're going to write to find that point P. Okay? Okie doke. So what we know is that the point P lies to the right of minus 5. Okay? We know that because we've already pretty much profiled our graph here. And that has already told us that information. So in this case, when x is bigger than minus 5, then the absolute value of x plus 5 is simply going to be x plus 5, because it will be positive. When x is bigger than minus 5, x plus 5 is positive, and so we can replace the absolute value with itself. So we will get the function x plus 5 minus 2 equals 0. This is the equation that we want to solve to find the intersection of the parabola with the horizontal line y equals 2. Okay? So now it's just a matter of quadratic formula, right? Or factoring, if that's possible, but it turns out in this problem that we're going to have to use the quadratic formula. So let's write that down. X squared plus 5x minus 2 equals 0. Okay? So I'm going to minimize this, and then we're going to go to town on the quadratic formula. So what's our A? Our A is 1, our B is 5, and our C is minus 2. Okay? So what do we get? We get minus 5, minus B, plus or minus the square root of B squared, which is 25, okay, minus 4A times C. So that's going to give us plus 8. 4 times 2 is 8, divided by 2A, which is 2. So you notice square root of 25 is 5, so square root of what we have here, which is 33, is going to be larger than 5. And that's important to know. So what we're going to have at the end of the day here is we're going to have minus 5 plus or minus square root 33 divided by 2. Okay? And the root P, our root P, will be the positive one of these two, and that will be minus 5 plus square root 33, this whole quantity, divided by 2. Okay? And that solves our problem. And that illustrates the technique, my technique, for solving inequalities in general, solving quadratic inequalities or absolute value inequalities. In a separate video, I'll talk about solving more complicated quadratics and also graphing more complicated absolute value functions. But there you have it. Good luck. Practice, please. Bye.